Welcome back to the deep dive. We always try to find the most interesting papers to really deep dive into, and you found a really good one this time.
Well, I thought it was pretty relevant to a lot of what we've been seeing, in the industry.
Yeah, definitely. And the title of this paper is a mouthful, but I think is really descriptive. It's called Monitoring Machine Learning Models: A Categorization of Challenges and Methods.
That's right. And as machine learning models, they're being used more and more for all kinds of different things, in the real world. And we really need to make sure that they are working like they're supposed to do once they're actually being used.
Yeah. We can't just set them and forget them, right?
Exactly.
So this paper really digs into two main things. First, it lays out all the different things that can go wrong or, make it hard to use these models effectively. And then it talks about how monitoring can help us deal with those challenges.
Right. It kind of gives us a roadmap for, making sure our models are doing what we expect them to.
I like that, a roadmap.
Yeah.
So let's start with the challenges. What's the first one that the paper talks about?
So the first one they talk about is high dimensionality. And, this basically means that the data and the models themselves are just really complex, lots of data points, lots of features, lots of different sources of data. And, the models themselves have a huge number of possible states. So it can be really hard to even wrap your head around it all, let alone monitor it effectively.
Right, and I imagine that just trying to process all that data and make sense of it must be a huge computational challenge in itself.
Oh, absolutely. And then on top of that, you have to worry about the quality of the data. Is it accurate? Is it complete? All of that adds another layer of complexity.
So just the sheer scale of the data and the models is a major hurdle right off the bat.
Exactly.
Okay, so what's the next challenge they bring up?
So the next one is something called data set shift.
Data set shift.
Yeah, and what that means is that the data that the model sees when it's actually being used is different from the data that it was trained on.
Oh, so it's like it's studied for one test and then got a totally different one on exam day.
Yeah, kind of. And, this can happen for all sorts of reasons, like maybe the way the data is collected changes, or maybe the world itself changes in some way. And that can really mess with the model's performance because it's not prepared for those new patterns.
So it's not just about how accurate the model is on the training data, but how well it can adapt to new and potentially unexpected data.
Exactly. And they actually break this data set shift down into different types, too.
Ooh, okay, how do they categorize it?
So there's covariate shift, and that means that the input features are different. Like maybe you trained a model to predict housing prices based on certain features, but then the types of houses being sold change. Maybe more people are buying condos or something like that.
I see.
And then there's prior probability shift, which means the distribution of the target variable changes. So in our housing example, maybe the overall prices go up or down, across the board.
Okay, and that would definitely impact the predictions.
Right. And then the last type is concept drift, which is maybe the trickiest one.
What's tricky about it?
Well, concept drift means that the actual relationship between the input features and the target variable changes over time. Like maybe at first location was a really strong predictor of housing prices. But then something happens, like a new school opens up or a major employer shuts down, and suddenly location isn't as important anymore.
Oh, wow. So it's not just the data itself that's shifting, but the underlying relationships within the data.
Exactly. And that's what makes concept drift so hard to deal with, because you're not just adjusting to new data, you're adjusting to a whole new set of rules.
That sounds really challenging for sure.
Yeah, it definitely keeps things interesting.
Okay, so we've got high dimensionality and data set shift.
hmm
What's the third challenge that they highlight?
So the third one is all about robust modeling. And this is basically making sure that your model can handle unexpected inputs and changing conditions.
Okay, so it's not just about being accurate in a perfect world. It's about being resilient in the real world.
Exactly. And they talk about two main aspects of this robustness. The first one is robustness to input data, meaning
Right.
meaning that the model shouldn't freak out if it encounters data that's a little bit noisy or has some errors in it.
Right, because real world data is never going to be perfectly clean.
Right, exactly. And this also ties into the idea of adversarial examples.
What are those?
Adversarial examples are basically inputs that are deliberately designed to trick the model into making a mistake.
So it's like someone's intentionally trying to break your model.
Yeah, basically. And it's a big concern in areas like security, where you don't want someone to be able to easily fool your system.
That makes sense.
Yeah,
So the model needs to be robust enough to withstand those kinds of attacks.
exactly. And the other aspect of robustness is robustness to changes in the model's configuration.
Meaning, like, if you tweak some of the parameters or update the model in some way.
Right. And this is where the KCE principle comes in.
Case principle.
Yeah, it stands for changing anything changes everything.
Oh, that's catchy.
And it's a really important concept because it means that even small changes to one part of the model can have ripple effects throughout the whole system. So you have to be very careful when you're making changes.
So it's like a delicate ecosystem where everything is interconnected.
Exactly. And that makes it even more important to monitor things closely so you can catch any unexpected consequences early on.
Okay, so we've got high dimensionality, data set shift, robust modeling.
Hmm.
What's next?
Okay, so the fourth challenge is system interdependence. And this one is all about the fact that machine learning models rarely operate in isolation. They're often part of a larger system with lots of different components and dependencies.
So it's not just about the model itself, but about how it interacts with everything else.
Exactly. And they talk about two main types of dependencies. First, there are dependencies on external data pipelines, things like ETL processes that extract, transform, and load data.
Right, because the model needs data to work with, and that data has to come from somewhere.
Exactly. And if there's a problem with that pipeline, like maybe the data is delayed or corrupted, then the model's going to be in trouble.
That makes sense.
And then the other type of dependency is dependencies between different machine learning models themselves. Like you might have one model that outputs predictions that are then used as inputs for another model.
Oh, wow, so it's like a chain reaction.
Exactly. And if one model starts making mistakes, those mistakes can propagate through the whole system.
And I imagine that would make it really hard to pinpoint where the problem is originating.
Yeah, exactly. And that's one of the big challenges with system interdependence. It can be really hard to track down the root cause of a problem because everything is so interconnected.
So managing these interdependencies must be a key part of ensuring that the whole system runs smoothly.
Absolutely. And that's where monitoring comes in. You need to be able to keep an eye on all the different parts of the system and how they're interacting so you can catch problems early on.
It sounds like a complex but critical aspect of operating machine learning models in the real world.
It definitely is.
So what's the fifth challenge on the list?
Okay, so the fifth one is result communication. And this one is all about the fact that many machine learning models are kind of like black boxes. They can make predictions, but it's not always clear how they arrived at those predictions.
Right. So you might have a model that's really accurate, but you don't really understand why it's making the decisions it's making.
Exactly. And that can be a big problem, especially in areas where explainability is important, like healthcare or finance. People want to be able to trust the model's predictions, and that trust often comes from understanding how those predictions were made.
So it's not just about accuracy, it's about transparency as well.
Exactly. And this lack of transparency can also make it harder to debug the model if you don't know why it's making a mistake. It's harder to fix it.
Makes sense.
And they also point out that sometimes there's actually a trade-off between performance and transparency, meaning that the most accurate models are often the most complex and the hardest to interpret.
So you have to choose between a model that's really good at making predictions but hard to understand, or a model that's easier to understand but maybe not as accurate.
Right. And finding that right balance is really important. And it depends a lot on the specific application. What are the stakes? What are the consequences of a wrong prediction? All of that has to be taken into account.
It's a fascinating challenge, and it really highlights the need for tools and techniques that can help us peek inside those black boxes and understand how they work.
Absolutely.
So what's the final challenge that the paper discusses?
The last one is test design and validity. And this is all about the fact that it can be really hard to test machine learning models, especially adaptive models that are constantly learning and evolving.
Yeah, it does sound tricky. How do you design a test for something that's always changing?
That's the million-dollar question. And they talk about something called the oracle problem, which is basically the idea that for a lot of machine learning tasks, there's no single right answer, especially in areas like recommendation systems. What's the right recommendation? Well, it depends on the person, what they're looking for.
So there's no ground truth to compare the model's predictions to.
Right. And that makes it really hard to say definitively whether the model is doing a good job or not.
And on top of that, the data itself is changing all the time. So even if you could design a perfect test today, it might be obsolete tomorrow.
Exactly. And that's why traditional pre-deployment testing isn't always enough for machine learning models. You need to have ongoing monitoring in place to track how the model's performing in the real world and adjust your testing strategies as needed.
It sounds like monitoring is essential for ensuring that these models are not just accurate in a lab setting, but also effective and reliable when they're actually deployed.
Absolutely. It's the only way to really know how your models are behaving and to catch problems before they turn into major issues.
So we've covered 6 major challenges in operating machine learning models: high dimensionality dataset shift, robust modeling system, interdependence, result, communication and test design, and validity.
Mm-hmm. That's a pretty good summary.
And now the paper shifts its focus to monitoring as a potential solution to these challenges, right?
Exactly. They propose this whole framework for monitoring machine learning models, and they break it down into two main branches: data monitoring and model monitoring.
So it's about keeping an eye on both the data that's going into the model and the model itself.
Precisely, and they emphasize that monitoring needs to be continuous. You can't just check things once and assume everything is fine.
It's about ongoing vigilance, constantly looking for signs of trouble or opportunities for improvement.
Exactly, and this continuous monitoring allows you to be much more proactive. Instead of waiting for something to break, you can catch potential problems early on and take steps to prevent them from becoming major issues.
So it's like having a smoke detector instead of waiting for the whole house to catch fire.
Exactly, and that's why monitoring is becoming such a crucial part of machine learning development and deployment. It's the key to ensuring that these models are reliable, effective, and ethical.
Well, this is a great starting point, and I'm already really intrigued to learn more about the specifics of this monitoring framework they're proposing.
Yeah, me too.
Let's dive into that in our next segment.
Sounds good.
All right, so we're back and ready to dig into the specifics of this monitoring framework.
Yeah, let's pick up where we left off with data monitoring.
Sounds good. You mentioned observation-based validity and cross-batch validity.
Right, those are kind of the two main approaches to data monitoring.
Okay, so let's start with observation-based validity.
Yeah.
How do they define that in the paper?
So observation-based validity is all about checking individual data points to make sure they meet certain criteria, kind of like a quality control check for each piece of data.
So it's like looking at each ingredient before you put it in the cake.
Exactly. And the way they formalize this is with something called predicates. Yeah, basically predicates are just rules or constraints that define what valid data should look like.
So it's like a set of tests that each data point has to pass.
Exactly, and they break these predicates down into 3 dimensions: completeness, consistency, and correctness.
Okay, so completeness meaning?
Completeness just means that all the required data fields are there.
Yeah.
Like if you're collecting data about customers, you want to make sure you have their name, their address, their email, all the essential information.
Right, you don't want any missing pieces.
Exactly. And then consistency is about making sure the data is formatted correctly and that the relationships between different data points make sense. Like if you have a date of birth, it should be a valid date and it should be before the customer's purchase date.
So it's about internal consistency within the data itself.
Right. And then correctness is about making sure the actual values are valid. Like a customer's age shouldn't be negative or their zip code shouldn't be a random string of letters.
So it's about making sure the data makes sense in the context of the real world.
Exactly. And all of these checks, completeness, consistency, correctness, they can be automated using different tools and techniques.
Oh, so you don't have to manually inspect every single data point.
No,
Yeah.
thankfully not. There are tools out there that can do a lot of this heavy lifting for you.
Can you give some examples?
Sure. One example is Data Linter. It's a tool that can automatically scan your data for things like missing values, incorrect data types, outliers, stuff like that.
So it's like a spell checker for your data.
Kind of. And then there's another tool called Boost Clean, which is specifically designed to detect violations of typical domain values, like if you have a data set of customer purchases and suddenly you see a purchase for $1 million, that might be a red flag.
Yeah, that would definitely raise some eyebrows.
Exactly. And these tools can be really helpful for catching potential data quality issues early on before they have a chance to mess up your models.
So it's a proactive approach to data quality management.
Right. And that's really the whole point of data monitoring, to catch problems before they become big headaches.
Okay, so we've talked about observation-based validity, which is about checking individual data points.
Mm-hmm.
Now let's move on to cross-batch validity. What's that all about?
So cross-batch validity is about comparing different batches of data to see if there are any significant changes in the distribution of the data.
So instead of looking at individual data points, you're looking at the overall characteristics of the data.
Exactly. And this is really important for detecting things like data set shift. If the data you're using to train your model is different from the data the model is seeing in the real world, that's going to cause problems.
Right. We talked about that earlier.
Yeah, and the way they approach cross-batch validity is, again, with predicates, but this time the predicates are applied to the whole batch of data instead of individual data points.
So you're basically defining rules for what a valid batch of data should look like.
Exactly, and these rules can be based on things like the mean, the standard deviation, the range of values, any kind of statistical measure that can help you characterize the data.
So you're looking for any significant deviations from the expected norms.
Precisely. And they talk about different approaches to doing this. Some approaches are schema-based, meaning that you define a schema up front that specifies the structure and characteristics of your data, and then you check each batch against that schema.
So it's like having a blueprint for your data.
Exactly. And then other approaches are schemaless, meaning that you don't define a schema beforehand. Instead, you let the algorithm learn the characteristics of the data on the fly and then flag any deviations.
That sounds more flexible, but maybe also more complex.
It can be, yeah. It really depends on your specific needs and the complexity of your data.
So they're kind of like two different philosophies for approaching cross-batch validity.
Right. And they both have their pros and cons.
Can you give some examples of specific tools or techniques that are used for cross-batch validity?
Sure. One example they mention is data diff, which is a schemaless approach that determines the difference between two data sets by finding the minimal set of changes needed to transform one data set into the other.
So it's like finding the shortest path between 2 points in data space.
Kind of. And then another technique they talk about is novelty detection, which is specifically focused on identifying individual data points that are unusual or unexpected.
So it's like an outlier detection system.
Exactly. And novelty detection can be really helpful for catching things like data errors or anomalies that might indicate problems with your data collection process or even malicious activity.
So it's another layer of protection for your data.
Right. And all of these techniques, schema-based, schema-less, novelty detection, they're all part of the toolkit for ensuring that your data is high quality and that your models are getting the right inputs.
It sounds like a pretty comprehensive approach to data monitoring.
It is, and it's becoming increasingly important as machine learning models are being used for more and more critical applications.
Now, the paper also talks about some non-technical aspects of data monitoring, right?
Yeah, they touch on some economic and ethical considerations.
Okay, let's start with the economic side of things. What do they say about that?
So on the economic side, they basically point out that data monitoring isn't free. It takes time and resources to collect and validate data, so you have to weigh those costs against the potential benefits.
So it's about finding that sweet spot where you're getting the most value out of your data monitoring efforts.
Exactly. And one way to do that is to be strategic about which data you're collecting and validating. If some features are highly correlated with each other, maybe you don't need to collect data for all of them.
So it's about prioritizing the most important data and making sure that you're not wasting resources on redundant or irrelevant information.
Right, and that can save you a lot of time and money in the long run.
Now, what are the ethical considerations? What do they have to say about that?
So on the ethical side, they talk about the importance of being mindful of potential biases in your data and how those biases can affect your model's predictions.
Right, because if your data is biased, your model is likely to be biased as well.
Exactly. And this can lead to all sorts of problems, like discrimination or unfair treatment.
And this is especially important when you're dealing with sensitive data like age, gender, race, things like that.
Absolutely. You have to be very careful about how you use that kind of data. And you need to make sure that your models aren't perpetuating existing biases.
So data monitoring can actually play a role in ensuring that your models are fair and ethical.
It can, yeah. By monitoring your data for potential biases, you can catch problems early on and take steps to mitigate them.
It sounds like data monitoring is about a lot more than just technical accuracy. It's about ensuring that your data is high quality, cost-effective, and ethically sound.
Exactly. It's a multifaceted task that's becoming increasingly important as machine learning becomes more pervasive in our lives.
This has been a great overview of data monitoring. Now let's shift gears and talk about model monitoring.
Sounds good to me.
What are some of the key things we should be thinking about when it comes to monitoring the models themselves?
Well, the first thing to understand is that model monitoring is really about tracking a whole bunch of different metrics that can tell you how well the model is performing.
Metrics like accuracy and precision.
Those are definitely important, but there are a lot of other metrics to consider as well. Things like robustness, confidence, interpretability, even economic factors.
Okay, so it's a much broader view than just focusing on how often the model gets the right answer.
Exactly. It's about understanding how the model is behaving in the real world and making sure that it's meeting all of your requirements.
So let's break those different metrics down a bit, starting with performance metrics. What are some of the key performance metrics that we should be tracking?
Well, it depends a lot on the specific type of machine learning task you're doing.
Yeah.
Classification, regression, clustering, each one has its own set of relevant metrics.
Right, so for classification tasks where you're trying to predict which category something belongs to.
Right. For classification, you might look at things like accuracy, which is just the overall percentage of correct predictions.
Okay, so how often the model gets it right?
Exactly. And then there's precision, which is the proportion of true positive predictions among all positive predictions.
So out of all the things that the model flagged as positive, how many were actually positive?
Exactly. And then there's recall, which is the proportion of true positive predictions among all actual positive instances.
So it's about how many of the actual positives the model was able to catch.
Right. And then there's the F1 score, which
Hmm.
is kind of a combination of precision and recall. It gives you a single number that represents a balance between the two.
So it's a more holistic view of the model's performance.
Exactly. And all of these metrics can be really helpful for understanding how well your classification model is doing.
Now, what about regression tasks, where you're trying to predict a continuous value?
Right. For regression, there are different metrics to consider, things like mean absolute error or MAE.
Which
MAE is just the average difference between the predicted values and the actual values. So if your model is predicting house prices and it's consistently off by $10,000, then your MAE would be $10,000.
Okay, so it's a measure of how far off the predictions are on average.
Exactly. And then there's root mean squared error, or RMSE, which is similar to MAE, but it gives more weight to larger errors.
So if the model makes a few really big mistakes, those are going to have a bigger impact on the RMSE.
Right. And then there's R squared, which is a measure of how well the model fits the data.
Yeah.
It tells you what percentage of the variation in the target variable is explained by the model.
So a higher R squared means a better fit.
Exactly. And again, all of these metrics are important for understanding how well your regression model is performing.
Now, the paper also emphasizes the importance of monitoring these performance metrics over time.
Oh, absolutely. You can't just look at a single snapshot in time. You need to see how the metrics are trending over time.
Why is that so important?
Well, it's important because it can help you detect problems early on. If you see a sudden drop in accuracy or a spike in error rates, that could be a sign that something is wrong.
So it's like a canary in the coal mine.
Exactly. And it can give you a chance to investigate the problem and fix it before it causes serious damage.
It sounds like continuous monitoring is really essential for ensuring that your models are staying on track.
It absolutely is.
All right, so we've covered performance metrics. Now let's move on to robustness metrics.
Okay, so robustness metrics are all about understanding how well your model can handle unexpected inputs or changes in its environment.
So it's about testing the model's limits and seeing how it responds to stress.
Exactly. And there are a lot of different ways to measure robustness. One common approach is to use adversarial examples.
Okay.
Adversarial examples are inputs that are specifically designed to trick the model into making a mistake.
So it's like you're deliberately trying to break the model.
Kind of, yeah. The goal is to see how vulnerable the model is to these kinds of attacks.
And why is that important?
Well, it's important because in the real world, your model is going to encounter all sorts of unexpected inputs. Noisy data, corrupted data, even malicious data.
Right. And you want your model to be able to handle those situations gracefully.
Exactly. You don't want it to fall apart at the first sign of trouble.
So how do you actually create these adversarial examples?
There are a lot of different techniques, but one common approach is to start with a valid input and then make small changes to it until the model makes a mistake.
So you're basically poking and prodding the model to see where its weak points are.
Exactly. And by doing that, you can get a better sense of how robust the model is and what kinds of inputs it might be vulnerable to.
That's fascinating.
Yeah, it's a whole field of research in itself.
Yeah, the paper also mentions fuzzy testing and symbolic execution as techniques for assessing robustness.
Right. Fuzzy testing is basically about throwing a bunch of random or slightly modified inputs at the model and seeing how it responds.
So it's a more brute force approach.
It is, yeah, but it can be surprisingly effective at uncovering bugs or vulnerabilities.
And what about symbolic execution?
Symbolic execution is a more formal technique that involves analyzing the model's code to systematically explore all possible execution paths.
So it's a more thorough, but also more computationally expensive approach.
Exactly, and it's often used for safety-critical applications where you need to be absolutely sure that the model is behaving correctly.
So both fuzzy testing and symbolic execution have their place in the robustness testing toolkit.
Absolutely, it really depends on the specific application and the level of rigor required.
Okay, so we've talked about performance metrics and robustness metrics.
hmm
What about confidence metrics? What are those all about?
So confidence metrics are all about understanding how certain the model is about its predictions.
So it's like the model's own assessment of how confident it is in its answers.
Exactly. And a lot of machine learning models can actually output a confidence score along with their predictions.
So it's not just saying, this is what I think. It's saying, this is how sure I am about it.
Right, and those confidence scores can be really valuable for a number of reasons.
Like,
Well, for one thing, they can help you identify predictions that might be risky or unreliable. If the model's only 50% confident about a prediction, maybe you don't want to make any big decisions based on that.
right, you might want to get a second opinion or gather more data.
Exactly. And confidence scores can also be used to trigger actions. Like if the model is below a certain confidence threshold, maybe you want to send the prediction to a human expert for review.
So it's about using the model's own self-awareness to improve the overall decision-making process.
Exactly. And that's why confidence metrics are becoming increasingly important in machine learning.
Now, the paper also mentions calibration in the context of confidence metrics. What exactly does calibration mean?
Calibration is about making sure that the model's confidence scores actually reflect its true accuracy.
So if the model says it's 80% confident about a prediction, it should actually be right about 80% of the time.
Exactly. And if that's not the case, then the model is miscalibrated, and that can lead to problems because you might be making decisions based on faulty confidence estimates.
So calibration is about ensuring that the model's confidence is trustworthy.
Precisely. And there are techniques for calibrating models to improve their confidence estimates.
It sounds like a crucial step in making sure that you're not being misled by the model's own self-assessment.
It is, and it's something that's often overlooked, but it can make a big difference in the reliability of your models.
Okay, so we've talked about performance metrics, robustness metrics, and confidence metrics. What's next?
Next up, we have economic metrics.
Economic metrics meaning?
Meaning metrics that relate to the cost of operating the model.
Yeah.
Things like training costs, inference costs, and the overall return on investment.
Right, because machine learning models can be expensive to develop and deploy, so you want to make sure that you're getting your money's worth.
Exactly. And economic metrics can help you track those costs and make sure that your models are actually delivering value.
Can you give some examples of specific economic metrics that might be tracked?
Sure, one important metric is resource consumption. How much computing power, memory, and storage does the model use during training and inference?
Right, because those resources cost money.
Exactly. And if you can optimize your model to use fewer resources, that can save you a lot of money.
So it's about finding that balance between performance and efficiency.
Right. And then another important economic metric is the cost of model actions.
What does that mean?
Well, it means that if your model is making decisions that have real-world consequences, like approving loans or trading stocks, then those decisions have a cost associated with them.
Right, because if the model makes a bad decision, it could cost you money.
Exactly. And so you need to track those costs and make sure that the model's decisions are aligned with your business goals and risk tolerance.
So it's not just about how accurate the model is, it's about how much money it's making or losing you.
Precisely. And that's why economic metrics are becoming increasingly important in machine learning, especially as models are being used for more and more high-stakes applications.
It makes sense. It's about making sure that your models are not just technically sound, but also financially viable.
Exactly.
Okay, so we've covered performance, robustness, confidence, and economic metrics. What's left?
Two more categories, interpretability metrics and ethical metrics.
Okay, let's start with interpretability. What does it mean for a model to be interpretable?
Interpretability is all about understanding how the model is making its decisions. What features is it using? What logic is it following?
So it's about being able to peek inside the black box and see how it works.
Exactly. And this is really important for a number of reasons. First of all, it can help you build trust in the model. If you understand how it's working, you're more likely to trust its predictions.
Right. It's like the difference between trusting a doctor who explains their diagnosis and one who just gives you a prescription.
Exactly. And then interpretability can also help you debug the model. If you know how it's making its decisions, you can more easily identify and fix errors.
And it can also help you ensure that the model is fair and unbiased, right?
Absolutely. If you can see how the model is using different features, you can make sure that it's not discriminating against certain groups of people.
So interpretability is really about making sure that your models are transparent, accountable, and fair.
Exactly. And there are a lot of different techniques for making models more interpretable, things like feature importance analysis, partial dependence plots, and even just visualizing the model's decision boundaries.
So it's a whole field of research in itself.
It is, yeah, and it's becoming increasingly important as machine learning models are being used for more and more sensitive applications.
Now, what about ethical metrics? What are those all about?
Ethical metrics are about making sure that your models are aligned with your values and that they're not causing harm.
So it's about the moral implications of using machine learning.
Exactly. And this is a really complex and evolving area, but there are a few key principles that are starting to emerge.
Like what?
Well, one important principle is fairness. Making sure that your models aren't discriminating against certain groups of people.
Right, we talked about that a little bit in the context of interpretability.
Yeah, and there are a lot of different ways to define and measure fairness, so it's an ongoing area of research.
And what are some other ethical principles?
Another important principle is privacy. Making sure that you're not using people's data in ways that they wouldn't expect or consent to.
Right, because machine learning models can be very data hungry, and it's important to be respectful of people's privacy.
Exactly. And then another principle is accountability. Making sure that someone is responsible for the decisions that the model makes.
So if the model makes a mistake, someone needs to be held accountable.
Right, and this is especially important for high-stakes applications like healthcare or finance.
It sounds like ethical considerations are becoming increasingly important in machine learning.
They definitely are, and it's a conversation that we need to be having as society. What are the ethical implications of using these powerful technologies, and how can we make sure that they're being used for good?
Well, this has been a really fascinating and thought-provoking discussion about model monitoring.
Yeah, it's a complex topic, but it's really important to understand.
Absolutely. It's clear that monitoring is essential for ensuring that our machine learning models are reliable, effective, and ethical.
I completely agree. It's the key to building trust in these technologies and making sure that they're used responsibly.
So what's next in this deep dive?
Well, now that we've covered all the different aspects of monitoring, I think it would be helpful to look at some concrete examples of how this is being done in practice.
Yeah, let's see how these concepts are being applied in the real world.
Sounds good to me.
Welcome back to the deep dive. We've talked a lot about the challenges of operating machine learning models and all the different things you need to monitor.
Right, we've covered a lot of data quality, performance metrics, robustness, interpretability, ethical considerations, the whole shebang.
It's a lot to keep track of, but it's clear that monitoring is essential if we want to use these models responsibly and effectively.
Absolutely. It's not just a nice to have, it's a must have.
And the paper we've been discussing really drives that point home.
Yeah.
They provide this whole framework for categorizing the challenges and the methods for monitoring.
Yeah, they've done a great job of laying out the landscape. What are the potential pitfalls and what are the tools and techniques we can use to avoid them?
Now, the paper also talks about how they validated this framework using case studies.
Right. Yeah, they looked at examples from the AI incident database, which is basically a collection of documented AI failures.
Oh, wow. So it's like a museum of AI mistakes.
Kind of, yeah, but it's a really valuable resource because it shows you what can go wrong in the real world, when these models are actually deployed.
So it's not just hypothetical scenarios. They're real-world examples of things that have actually happened.
Exactly. And a lot of these incidents they highlight could have been prevented or at least mitigated with proper monitoring.
So it's a reminder that monitoring isn't just about being careful. It's about preventing real harm.
Absolutely. These models are being used for increasingly important decisions, and we need to make sure that they're working as intended.
So studying these case studies can give us valuable lessons about what to watch out for and how to design our monitoring systems.
Definitely. It's like learning from the mistakes of others so we don't have to make them ourselves.
All right, so we've talked about the theory of monitoring. We've looked at some real-world examples of what can go wrong. But how do we actually put all of this into practice?
That's the big question, right? How do we actually implement a monitoring strategy?
Exactly. Where do we start?
Well, the good news is that there are a lot of tools and platforms out there that can help us with this.
Oh, that's good to hear. I was worried we might have to build everything from scratch.
No, no, there's a whole ecosystem of monitoring tools available, both open source and commercial.
So we have options.
We do. And the right tool for you is going to depend on your specific needs. What kind of models you're using, what kind of data you have, what your budget is, all of that.
Can you give us a quick overview of some of the popular tools and platforms?
Sure. So if you're working in the cloud, like AWS or Google Cloud, they have their own monitoring services.
Like what?
Well, AWS has Amazon SageMaker Model Monitor, which is specifically designed for monitoring machine learning models. And then Google Cloud has TensorFlow Extended, which is a more comprehensive platform for managing the entire machine learning lifecycle, including monitoring.
So if you're already using those cloud platforms, it might make sense to use their monitoring tools as well.
It often does, yeah. And then there are also open source tools like MLflow, which is a really popular platform for managing machine learning experiments and models. And it also has some monitoring capabilities.
Okay, and what about Evidently AI? I heard good things about that one.
Evidently AI is great. It's specifically focused on monitoring for data drift and model drift. So if that's a major concern for you, it's definitely worth checking out.
And what about Y Labs?
Y Labs is another good option. They take a more holistic approach to monitoring, so they have tools for data quality checks, performance monitoring, root cause analysis, all sorts of stuff.
So they're kind of a one-stop shop for monitoring?
Yeah, you could say that. And they also have a really nice user interface, which is always a plus.
So it sounds like there are a lot of great options out there.
There are, yeah. And new tools are being developed all the time, so it's a really exciting space to be in.
Now, beyond specific tools, what are some general best practices for implementing a monitoring strategy?
Well, one of the most important things is to define your goals up front. What are you trying to achieve with monitoring? What are the key metrics you need to track? What are your thresholds for triggering alerts?
So it's about having a plan before you jump in.
Exactly. You don't want to just start collecting data without knowing what you're going to do with it.
And then once you have your goals defined, you need to choose the right tools for the job.
Right. And then it's important to start small and iterate. Don't try to do everything at once. Just focus on the most critical metrics and then gradually add more as you gain experience.
So it's an ongoing process of learning and refining.
Exactly. And it's also important to involve the right people. Monitoring shouldn't just be the responsibility of the data science team. It should be a collaborative effort between data scientists, engineers, business stakeholders, even legal and compliance teams.
So it's about breaking down silos and getting everyone on the same page.
Exactly. And then finally, don't forget about documentation. Make sure that you're documenting your monitoring procedures, your metrics, your thresholds, your response protocols, all of that.
Right, because if you don't document it, it's like it never happened.
Exactly. And documentation is also really important for accountability. If something goes wrong, you need to be able to show what you were monitoring, what thresholds you had in place, and how you responded.
So it's about covering your bases.
Exactly.
Well, this has been a really insightful discussion about machine learning model monitoring.
I agree. It's been a great deep dive.
We've covered a lot of ground, from the theoretical foundations to the practical challenges to the tools and techniques that can help us monitor our models effectively.
And I think the key takeaway is that monitoring is not just an optional add-on. It's an essential part of responsible AI development and deployment.
Absolutely. It's the only way to ensure that our models are reliable, effective, and ethical.
And that's ultimately what we're all striving for, right? To build AI systems that we can trust and that benefit society as a whole.
Well said. I think that's a great note to end on.
I agree.
Thank you for joining us on the Deep Dive. Until next time, stay curious.